something that we should know, I don't know whether we all know it, is that it is actually our decision whether we are going to live a long and healthy life or we'll become ill relatively quickly. It's our lifestyle which is determining the healthy lifespan. And there is very convincing research. For example, this study was done on over 100,000 people, and it's clear that having healthy lifestyle habits is increasing both lifespan and the health span. And I think the health span is even more important because we want to live healthy. It's not the point to live long if you are ill and you don't feel well. You want to be healthy and enjoy your life. Unfortunately, the only thing which we really know it works in a lifestyle is the caloric restriction. So something what works in everybody is we eat less, we live longer. For example, this monkey here is on a low-calorie diet for 20 years. It looks healthier than his brother who had a normal diet. I'm not sure he looks happier. You know, when you look into his eyes, I think he's saying, oh, I'm hungry. So personally, I would choose this lifestyle and live a little bit shorter, but not be hungry for the rest of my life. And many people do a similar decision. And actually, the life expectancy is not increasing anymore, especially not in US. In US, it plateaued a number of years ago. So these are some other countries in the world. This is the US. So there is no increase in life expectancy. And actually, we had this sharp decline in pandemics, partly because of virus, but even more because of the decisions we made to change our lifestyle during the pandemic. And I think the key problem we have is we don't know what is healthy, because everything what we know in medicine is based on a concept of standard human. So you take 1,000 people, make an average, and then make a decision what is good for these 1,000 people. And you know, we are all not the same. We don't have this situation here, that we are all the same. We are all different. And this is why the only thing which works for everybody is this hungry monkey, not eating. For everybody else, it would be a different ratio of taking care of your diet, of your sleep, of your stress, of your physical activity. And it's not equal in everybody. So each of us has to find out what is the most important for us. And this is not easy. There is no way to know what kind of lifestyle will affect my longevity until I get old and sick. And I don't want to wait until then to learn. So the idea is, let's develop biomarkers. And for decades, people have been focusing on genes. We invested hundreds of billions into sequencing our genomes with very little translation. So all this investment, all this knowledge resulted in very little translation. And when we talk about longevity, I don't think there will be much more translation because only 20% of longevity is genetic. 30% of complex diseases is genetic. Everything else is actually our lifestyle and our decisions. And when we look into the genes and their translation into the phenotype, there are so many layers of interactions, gene environment, different metabolites. So it's very hard to measure something here and expect to see outcome as a complex phenotype. So we need some other things where we have to look into. And of course, the best thing are glycans. And believe it or not, glycans are the first biomarkers which have been used in patient stratification. We use them for more than 100 years. It's the blood groups. Blood groups are chemically glycans, just people don't think about them in that way. So what makes us different are glycan. And glycans can do it because they add additional layer of complexity between gene sequence and a protein function. So majority of proteins, at least all those, nearly all those which evolved after the life became multicellular, are glycoproteins. So they would have a polypeptide part and a glycan part. Polypeptide part is defined by a gene. So the gene sequence can change only by random mutation and a selection in the next generation. This changes very slowly. But the glycan structure is encoded in a complex network of genes. All the polymorphisms, all the epigenetic regulation, all the interaction with metabolism. It integrates into chemical structures, the glycans, which are added to a specific glycosylation site. So from functional point of view, alternative glycosylation, putting different glycan to the same glycosylation site, is analogous to coding mutation. It changes the protein structure. Everybody knows that the coding mutation can kill you. You have a wrong amino acid, protein doesn't work, you're gone. Alternative glycosylation can do a very similar thing. But from informational or evolutional aspect, it's not a gene sequence which changes very slowly. It's a complex trait. It's interaction of dozens or hundreds of different allelic variants which integrate, and they enable diversity without the risk to our genetic heritage, because a mutation is endangering everything we learned in the billions of years. Reshuffling allelic variants is making us different without endangering this heritage. And we show this very clearly in a paper we published actually 6 years ago in Nature Chemical Biology, where we looked over 100 different strains of mice, which were generated as a collaborative cross cohort starting from the 8 founder individuals, mixing allelic variants for 3 generations and then inbreeding. So they generated more or less clones of cousins or strains of cousins. And some of these strains became completely separated from the rest of the population based on their IgG glycome composition, meaning the structure and function of their immunoglobulins. They were completely different from the rest without any mutation, just by reshuffling allelic variants. And we see that also in the human population. So people are different. These are 6 random individuals, different color, different glycan, IgG glycome composition. So people are not the same in the way they glycosylate proteins, and this is a big part of variability between individuals, which is partly genetic, partly epigenetic, partly environmental. So allelic variants, that's evolutionary wisdom. We are inheriting this for millions of years. Epigenetic, everything what happened to us since conception until now, what we are eating, what we are thinking, what our mother was eating when we were not born yet, this all integrates into the complex network which decides which glycans will be synthesized and attached to proteins. And for example, for immunoglobulins, this is changing through age from structures which correlate with a higher inflammation to those which correlate with a lower inflammation. And as you heard earlier this morning, there is a lot of hidden information in glycome composition. You can just take the IgG glycome composition and predict serum calcium, serum albumin, HbA1c, biological sex, 100%, just based on IgG glycome composition. And my first reaction when I saw this, I said, that's overfitting. You just put too much information, you put it in a model, you overfit it. And then Alexander, who was presenting this morning, showed me the replication cohort. So this cannot be overfitting because it's a new cohort. It's a model translated to the new cohort, and still predictions are nearly equally good. So there is a lot of information in IgG glycome composition which we still do not understand. We cannot interpret it yet. But we know that as we are transitioning from a healthy state to a disease state, glycans are changing in the same way, and actually they change even before disease is being diagnosed. So what we have a chance here is not to wait for a complex disease, because all these chronic diseases, they're called chronic because once you get it, you have it for the rest of your life. You're a customer of big pharma, you take pills, you're alive, but you're sick. But if we identify it on time, then maybe a simple lifestyle change or a simple therapy could reprogram this mechanism which lead to disease, and then we remain healthy for longer. But we don't know, we don't know which diet works for everybody. There's no diet which works for everybody. And I think this is the reason why you have all these hundreds of magic books telling us which diet is the right diet, because each of them is probably right for somebody else. So we did a large study. 1,000 people, 800 calories per month, per day, for 2 months. They lost 10% of their body mass, and yeah, their IgG glycome switched to kind of a less pro-inflammatory IgG glycome within these 2 months. But nobody can live on 800 calories, that's a torture. So they were put on 5 different healthy diets, different combination of nutrients, things which were supposed to be good, and on each of the diets. Some people got better, some people got worse. So Nina will talk more about it. I will not go into details. I will just tell you there is no one-size-fits-all for diet. We are different. And I think the best example how really different we are is the lactase persistence. So that's a mutation which developed several times during the human evolution, which enabled humans to survive in the northern climate. So it was essential for survival. There is nobody on the north of Europe which does not have a lactase persistence. But this happened over 7,000 years ago, and still the majority of planet do not have this variant. So the majority of planet is lactose intolerant. Now imagine the high carb diet. It happened only a few thousand years ago, and the availability of food only happened maybe 100 years ago. So simply we are not genetically adapted to the high amount of foods, and each of us is different. Glycans can monitor what is going on. So these are not IgG glycans, these are the plasma glycans. But plasma glycans are kind of changing as you are progressing from healthy state to the insulin resistance. And the same glycans which are changing as we approach the insulin resistance, they're also predictive of our individual response to food challenge. So it was done by Tim Spector. He fed people a huge muffin and then quantified the glucose and the lipid spikes. And the same glycans which are predicting disease are predicting the response. And if you start losing weight, they go the opposite direction. So there are ways you can monitor, and there are ways you can change your glycosylation. Physical activity, again, we have a next presentation which will talk more about it. Just a short message here. People are different. There's no physical activity which is good for everybody. So we need large studies to be able to collect sufficient amount of data and then try to personalize things. And we started with the high throughput IgG glycan profiling 13 years ago. Maya was the first author on that study where we showed glycans change a lot with age. But not only with chronological age, they change with the lifestyle. Because when you plot GlycanAge against the chronological age, and when you look for the difference, this difference correlates with the insulin level, fibrinogen level, HbA1c, BMI, triglycerides, all the biomarkers we know are unhealthy. So by monitoring IgG glycome, we are kind of monitoring how much damage we did to ourselves with our bad lifestyle in the past years. And then we developed this GlycanAge test of biological age, which we believe is a functional effector of inflammation that can be modified with lifestyle and pharmacotherapy. So many things integrating into the glycan structure, which you kind of follow. And of course, I'm conflicted here. I'm an inventor on a patent. I'm a co-owner of a company. So you don't have to take my word on it. You have to look into the data. So this is data not coming from us. This is data coming from Qatar. They analyzed over 6,000 different molecular traits, more or less everything you can buy on the market to get the molecular profiling. And 9 out of the 20 strongest association with age are immunoglobulin glycans, IgG and IgA glycans. The others were the sex hormones. So there is a lot of information about age in glycans. And there was a large perspective paper published in Cell by the Biomarkers of Aging Consortium, which are kind of monitoring all the biomarkers, which clearly concluded that the GlycanAge is actually the only commercially used test to track response to lifestyle changes, and it also associates with multiple diseases. And the reason why glycans are the only ones which can actually be used is that we can quantify them better than anybody else in the world. This was a study we did with Mike Snyder on 800 longitudinal samples, and there were only 4 data points, which were more than 10% different than the past one. So this is combined biological and analytical variation through time. And when we talk about the GlycanAge test itself, and commercial is being done as a triplicate and then average with multiple standards, this is me, this is my IgG glycome, through time, but not analyzed as a batch. Analyzed as a single sample sent to the lab every few months. And then when you look at the numbers, they really don't change much with time, because we nearly completely eliminated analytical variation in quantification of the IgG glycome. And I think this is extremely important if you want to monitor individuals, because then when you see even a slight change, what was happening here to me, you think about why is this happening? And I didn't like it because also this one on top, that's one predicting heart attack and stroke. It was going down, it's protective. I said, okay, there's something going on which is increasing my risk of heart attack and stroke. I don't want to have it, so what's going on? I tried to test it, everything, and I found I had a cryptic root canal infection. Now, IgG glycome was detecting something which was completely hidden. I wasn't able to identify it until I actually went and checked every detail. And IgG glycome correlates and changes in most diseases. So nearly every disease where we looked, we saw a lot of change in IgG glycome, and many of these changes resembled accelerated aging. So last 4 bars here is aging, all other bars are different diseases, different glycans, many of them move in the same direction. And in many diseases, this happens up to a decade before diagnosis. I don't have time to go into details, but we have a large number of high-profile papers showing glycans change much earlier than the disease develops. And for example, they also predict mortality. This was studied with Sarah Haig, 400 or 500 pairs of twins looking into glycans. This cohort collected 30 years ago, so we had actual people who died. Glycans are predictive. This should be published soon. We did a similar thing with Riccardo Marioni in Generation Scotland. Again, glycans predict mortality. When we looked all around the world, 27 populations, different parts of the world, glycans strongly correlate with expected lifespan. So there is a lot of information about glycans. So what do we know about the regulation of glycans? For example, one thing we know that the hormones are very important. Estrogen, testosterone. So if you block sex hormones, your GlycanAge goes up drastically. If you give a hormone replacement, this does not happen. When you track the female menstrual cycles, they change a bit, but not really that much, so it's not an analytical problem, but you can see a pattern that happens through months. So we had 50 women giving samples for a week for months. Actually, changes in glycans are one of the first symptoms of perimenopause. So usually IgG glycans start to change before any other symptoms of perimenopause develop. And it can be drastic. So somebody can have a very good GlycanAge for years and then gain 20, 30 years in a couple of months, which can be then fixed with a hormone replacement therapy. The problem with the hormones, especially in perimenopause, they go crazy. They go up and down within a day, between days. So it's hard to quantify hormones. But what we have here is IgG integrating estrogen concentration for weeks. So it's kind of HbA1c for glucose, IgG glycome is for estrogen. But then we did a study with anastrozole, which is the inhibitor of aromatase, so it's blocking the synthesis of estrogen, and tamoxifen, which is antagonist of estrogen. So it binds to the hormone, but then kills the hormone, doesn't allow the activation of the hormone. And we see different effects. For example, completely unexpected. So where we have expected results is aromatase inhibitor, the estrogen go down, you see G0 going down, G0 going up, G2 going down, salicylic acid going down. But when tamoxifen was given to patients, we actually had an increase in salicylic acid, which is odd because it should go down, but apparently, tamoxifen actually raises the estrogen concentrations, and it's blocking the nuclear receptors, not the membrane receptors. So maybe actually the signaling here goes to the membrane receptors, which we don't understand. there are many people who are trying different interventions. For example, Tim Spector at one point in his life played with metformin, and he actually did manage to decrease his GlycanAge significantly. We even recorded an Instagram Live about it. But then when we did a proper placebo-controlled randomized trial of metformin, we realized that the entire cohort that we tested, there was only a single individual which actually responded beneficially. So the metformin is beneficial only in a small subset of people. So we shouldn't be taking just preventively, only people who do respond. And to be able to learn that, to be able to answer to all these questions, we have to do large studies. And GlycanAge is accumulating a large amount of data. And for example, something recently reported by them is that people have the best GlycanAge at the end of summer. Don't know why, but it's interesting. It's interesting to know that some kind of a lifestyle changes, spring and summer, your GlycanAge improves. So we have to do much more. And we have a lot of people working on that. This is the GANOS and the GlycanAge team. GANOS is doing mostly the research. GlycanAge is doing the translation. And I thank you all for your attention.